In this lecture, we're going to apply the stats to the game object. Currently, the file gets loaded, but the game object does not use the values from the scriptable object. One option would be to update the controllers to store these values. However, as we learned, Unity encourages a component composition approach. By defining the logic from within a controller, we would have to duplicate code for enemies and players. To avoid that scenario, let's create components dedicated to controlling the stats of a character. This way, the component can be reusable. Let's create a set of components for storing the values. We'll create one component for managing the health of a character. Another component will be responsible for handling the combat. Both components will need the stats to be functional. Let's get started. In the scripts/character folder, create a new C# file called health. Next, create another C# file called combat. In a future section, we're going to flesh out both components with logic for handling combat. For now, both components will store their respective data. Let's open both files in Visual Studio Code. As usual, we're going to organize our code. In the health file, remove the system namespaces. Next, empty out the class. Lastly, create a namespace called rpg.character around the health class. I'm going to repeat these steps for the combat component. Great, the components are ready. The next step is to create variables for storing the stats. Starting with the health component, define a public float variable called health points with an initial value of 0f. The variable will be public since the enemy controller component has the stats. Therefore, external classes will need to be able to modify this variable. Since the variable is public, it'll be modifiable through the Unity editor. However, the value will be configured programmatically. If someone wants to modify this variable, they should do so from the scriptable object, not the component itself. Let's prevent serialization. At the top of the class, add the system namespace. Next, apply the non-serialized attribute to the variable. We're going to repeat this process for the combat component. Switch over to this file. At the top of the file, add the system namespace. Next, define a public float variable called damage with an initial value of 0f. Lastly, add the non-serialized attribute. Same reason as before. This variable should not be modifiable directly through the Unity editor. We'll allow other team members to modify it through the scriptable object. The last step is to update these variables from the enemy controller file. Open this file. Let's cache the components from the class. At the top of the class, define a private variable called health component with the health class as the type. Add another variable called combat component with the combat class as the type. From the awake method, we can set these variables using the getComponent method. Set the health component variable to the getComponent health method. Next, set the combat component variable to the getComponent combat method. The last step is to update the variables in the components with the respective stats. Let's do so from the start method. I prefer to set components from the awake method. For updates, I like to use the start method. Technically, we could do both actions from either method. However, I like to separate both actions to keep my code organized and clean. In the start method, set the health component.health points variable to the stats.health variable. Next, set the combat component.damage variable to the stats.damage variable. We're going to repeat this process for the player component. Open the Player Controller file. You should be able to copy the variables, awake method, and start method to this file. We're finished. Both components should be applied to enemies and players. Head on over to Unity. Since all enemies should have combat capabilities, we should apply these components to the base prefab. This way, all prefab variants will have these components. Open the enemy base prefab in prefab edit mode. Add the health and combat components to the parent game object. Let's repeat this process for the player prefab. Enter the prefab edit mode for this prefab. Lastly, add both components. I knew I flew right by the solution. Most of these steps should be familiar to you. If anything felt confusing, I recommend reviewing previous sections. Everything we've done is a repeat of what we did before. Let's try testing our game by playing it. If we did everything right, errors should not appear on the console. The game should be fully functional. After confirming everything works, we can move on to updating the speed of the enemy. In our stats file, we have walking and running speeds. Both speeds should be applied to the enemy and the player. In the next lecture, let's begin toggling the speeds.